Anything you want to start with? Anyone? Do we need anything else from the previous sections? Any more graphing? Anything? Or we go to optimization? Anything? Anyone? So, no ideas for me? Nothing?
I think we're good to move on.
Okay, thank you for your help. Good. So optimization. It's a topic that is a huge branch of mathematics, like calculus, like algebra, like geometry, like trig. Optimization is huge. It deals with finding max-min for functions. It's a major topic like related rates in the previous chapter, right? So what are the steps here? Identical steps with the previous situation with related rates. We read the problem. We establish a relationship. We differentiate that function and then find its max-min. So a little bit, in a way, a little bit easier than related rates, because we are only dealing with one function, a function of one variable. We don't have several functions of time. So I'm going to try to look at problems that I have not looked at last night with the other class. I'm going to, after class, I'm going to post everything I did last night and what I'm doing with you now. Okay. Let's start with 52 on page 353. They're telling us to find the point on the hyperbola. So we are given x, y equals 8, which very easily can be solved for y. And I haven't even finished reading the problem, but I know how to graph 1 over x. Well, 8 over x has the same shape. So 1 over x is this. 8 over x, it will have the same identical shape. Okay, so again, find a point on the hyperbola that is xy equals 8, that is closest to the point 3 comma 0. So assuming this is 8 over x, again, the same shape, just and let's say the point 3 comma 0 is this. So find the point on the hyperbola that is the closest to the point 3 comma 0. Okay. Well, I know it must be this one that connects this point by a vertical line to y equals x, to y equals 0, to the x-axis. It doesn't matter. I don't really want to graph that. I'm going to say, let's say it's this point. This point, let's call it P. Obviously, it has to have coordinates x, comma, 8 over x. If x is x, the y value must be 8 over x. Now I would like to refresh your memory on the distance formula. The distance formula is x2 minus x1, everything squared, plus y2 minus y1, everything squared. And I have 2 points. And I'm going to say it doesn't matter which direction you want to go, so you can consider this one x2, this one x1, doesn't matter. x2 minus x1 plus y2 minus y1. Of course, squared. So at this point, I'll say this is the function that I need to work with. It's the function of x. I will try to clean it up if I can a little bit, although it's not really necessary because when I differentiate, I don't really care what's in there. I have to differentiate it anyway. But let's say x squared minus 6x plus 9 plus 64 over x squared. That's good enough. So let's regroup and discuss what we have accomplished. We read the problem. We drew whatever figure we needed to help us figure out what we are looking for. So we are looking to minimize this distance. We are asked to find, I didn't write it, minimum distance between this point and the graph of 8 over x. Now you could say, but what about this? How come that this is, well, obviously 3, 0 is much closer to this branch than to this branch, so there is no discussion here. Okay, so we denoted a point on the graph by P. We identified the x and y coordinates, and we said, okay, so let's remember we are talking about the minimum distance, so I have to create a function that gives the minimum, that gives the distance first of all, and then I have to find its minimum. We remember the distance formula, y2 minus y1 squared plus y2, x2 minus x1 squared plus y2 minus y1 squared, and then we plugged it in, x minus x2 minus x1, y2 minus y1, we squared them and we expanded. So we already have what we're looking for in the sense of the function. Sometimes the function is given to us, and that's a plus. But in this situation, the function wasn't given to us, so we had to find it. So we are going to differentiate the function. So this is 1 over 2, the square root of what you see there. But of course multiplied by the inner function prime. So when I differentiate x squared, I get 2x. When I differentiate negative 6x, I get negative 6. 9 prime is gone. And then minus, remember this is 64x to negative 2, which becomes negative 128x to negative 3. At this point, I will try to just rearrange it a little bit, and I see I can factor out a 2 to remove this 2. Not that it's necessary, but it makes it easier. So we have x minus 3 minus 64 over x cubed divided by the square root of x squared minus 6x plus 9 plus 64 over x squared. So I divided 2x by 2, or I factored out to simplify. 2x divided by 2, 6 divided by 2, and 128 divided by 2 is 64, and then x to negative 3 goes to the denominator. I don't have to do anything else. I know that critical numbers come from d prime being 0 or d prime being undefined. That's no such thing, because when this is 0, the distance is 0. So that's not possible. So the only possible critical numbers can come from d prime being 0. When a fraction is set equal to 0, only the numerator can be 0. X minus 3 to make that happen. Okay. We'll find the least common denominator, which is x cubed. And we have x to the 4th minus 3x cubed and minus 64. Again, a fraction is 0 only when the numerator is 0. And now let's see what we get. When we try to solve this equation, we don't really have a tool. I have my calculator, which is TI-86, which it has a wonderful feature, but of course I'll show you with this calculator as well. My 86 has a feature called poly, which is right here. So with second and poly feature, you'll see it says poly and order. By the order, it means the degree, 4. Now it's asking me to put the coefficients in descending order. 1, -3, 0, 0, and -64. So 1, -3, 0, 0, and -64. Then I only have to click solve. We have to obtain 4 solutions. However, see, it takes a while, unless the batteries are dying. So we will have 4 solutions. I'm assuming that 2 will be real and 2 will be imaginary. So let's see. So we found one solution, which is 4, 0. X equals 4, I meant to write. Y equals 0. And let's investigate the other 2. Okay. The other solution is -2.29 with y equals 0. You also see 2 more solutions here, and obviously this is an imaginary solution, 0.64 and 2.55, and we're not interested. This is 0.64 and -2.55. So 2 real solutions and 1 imaginary solution. Okay, I haven't discussed which gives what yet. I have to come back and show you how to do this with your calculator. Okay, in y equals, clear whatever you have, and we have to put in this function. It's a 4th degree function. Before I graph it, I have to refresh our memory on something. A 4th degree function with a positive leading coefficient has to do this. It has to come from infinity and go to positive infinity. Or why I discuss this? Because I don't know what viewing window. I have an idea, right? I know where to look because I already calculated the solutions with a different calculator, but I really don't know where the viewing window is. So what viewing window I should use. So not too much under, maybe it will not go to -10, maybe it will go to -50, but I just wanted to give you an idea. Okay, so we put in the function x to the 4th minus 3x cubed and minus 64. For now, let's say I'm going to start with zoom 6, which is the standard viewing window. It goes far below, but it has to come back to 4 because I already know the solutions. And I don't know why it's not coming back to 4. Let me see what I plugged in. Ah! How did that happen? Okay, let's try again. It doesn't like something. I hope you got the correct graph. I'm going to clear and start from scratch. So x to the 4th minus 3x cubed minus 64. Okay, again, zoom 6. Okay. So I know that it has to look like this. I wasn't expecting it to go that far down, but that's okay. So I'm just going to change the y minimum because I want to see the entire graph. Let's say to -100 with a scale of 10. I just want to see the graph now. I'm curious. I know the solutions. We'll find the solutions. Okay. So as expected, the graph has to look like this. I will determine this solution and I will determine that solution. That appears to be exactly 4. Let's say we don't know. So I go to second and calc. I know, though, that the solution is between -3 and -2. So second and calc, and I want the 0. And between -3 and -2, give me the 0. and it has to be negative 2.29. Now I need to determine the positive solution. Let's say I don't know, and I say it's between 3 and 5. Second on calc, a 0. Between 3 and 5, and give me the solution, and it gives me 4. So this is how you do it with TI-84. Any questions for me? Stop me, please. Any questions? Anyone? However, I found 2 solutions, but I haven't told you anything about anything. Meaning, who knows if this is the minimum or not the minimum? What is it? So here is the last step in which I have to convince you. I don't need this one anymore. I have to convince you whether it's a max or a min. Okay, so we have x. Let's say x can be between negative infinity and infinity. We know we cannot be 0, right? It's 8 over x. And this is our d prime. And we found 2 options, one option which is 4, and the other option which is negative 2.29, and these are the critical numbers of the function. And now I have to study the sign to see what is the sign here, what is the sign here, and so on and so forth. I already graphed this function at the top, but I didn't graph it taking into account x to the third in the denominator, though. So that will change everything. So what I'm going to do is, one option is just plug in a number here, let's say negative 7. Plug in a number, let's say negative 1. Plug in a number like 3. Plug in a number like 5. And I will get the sequence of signs for the derivative. I will not plug in anything in the denominator. Why? It's always positive. There is no need. I'm not going to waste my time. But I have to plug in this expression to study the sign. So go to y equals and clear and just put that in, because this is always positive. So just x minus 3 and minus 64 divided by x to the third. I like to put that in parentheses. So x and caret and 3 and close the parenthesis. And I'm just going to plug in exactly what I said. With second and table, I will plug in negative 7. I will plug in negative 1. I will plug in 3. And I will plug in 5. So let's see what I get for negative 7. I get negative. Let's see what I get for negative 1. For negative 1, I get positive. Let's see what I get for 3. I get negative. Let's see what I get for 5. And I get positive. And now we have to draw the conclusion. So, negative 2.29 will be somewhere here. Negative 2.29 for x. And the other one, so this point. And the other one will have x equals 4. So the point will be 4 comma 2, and the other point will be y equals 8 over negative 2.29. What are we getting here? Negative 0.29 comma, how much is 8 divided by 2.29? Negative 3.49. So we get 0.4 comma 2 was so negative 2.29 and negative 3.49 and 4 comma 2. I see. Very good. So actually the point is right here at 4, 2. So this is the distance. It appeared initially that it was this, but apparently because it gets closer and closer, it makes sense, gets closer and closer to the horizontal asymptote, this will be the point. And this will be the other point. But let's analyze what happens here. So we study the sign of the derivative. The derivative was just this. I'm just making sure that I didn't miss anything. So we solve the equation. Okay, did I put x cubed? I put x cubed in the denominator. Okay, so the function, obviously, d of x. So the function obviously decreases, increases, decreases, and increases according to the sign of the derivative. And we are asked to find the minimum distance. We do have 2 points. Now we will decide which one is the minimum after we determine the y value. It appears that we have two minima, right? But once I plug in the function this, and I plug in the function this, I will draw a conclusion. That's the final step. Go back. Now we have to put in just the distance function in there. So second and square root, x squared. Oh, I'm going to put this one because it's compact and it's easier. I have to evaluate the function at 4 and the function at negative 2. So I already know where the points are, but I need to determine the distance. Okay, so x in parentheses, x minus 8, x minus 3, everything squared, plus, in parentheses, 8 divided by x, and everything squared. Don't forget to close the parenthesis under the square root, second and table. Okay, I plug in negative 2.29, and I plug in 4. Now let's see what we get. With this point, the distance is 6.339, and with 4, the distance is 2.2. And then, obviously, we know that this is the correct answer. So we'll say, because this is smaller than this, and we want the minimum distance. This distance is 6, this one is 2. So as the final answer, we will write the point P 4, 2 is the closest to the point 3, 0. It was a very interesting situation in which I was hoping to get a reversed plus negative and negative plus, and then I would say, okay, that's done. This is a maximum, this is a minimum. But it happened that both of them had followed the same pattern, and I had no choice. I had to plug in x in the distance function to see which one is the smallest. So the point is negative 2.29 this, but the distance to 3, 0 is this. Right? So between this point and this point, the distance is this. And obviously this is the smallest. This is 2 and this is 6.